Marco Codes! Hi folks, Marco here. Let's continue building our Google Photos clone. In the last episode, we started extracting thumbnails from images, and we made that single-threaded. Now let's multi-thread this whole thing, and along the way learn a ton about parallelism, what a tough word to say, multi-threading, and maybe even premature optimization. Sounds like fun? Let's go! Alright, let's look at our code again. We essentially have this main method where we let the user specify a program argument, being the directory containing all the images we want to create thumbnails for. And then down here, we use Java's file API to just sequentially walk that source directory, filter for regular images and ignore directories and non-images, and then just call ImageMagick.createThumbnail. How would we go about multi-threading this? Well, I thought, hey, Java streams have a .parallel method, and maybe this just works. That would just be a quick win. I don't know how many threads are being used under the hood here. I would need to, read up on that in the documentation, but why don't we just give that a go? And for easier debugging, I'm just going to go to the createThumbnail method, where we have this log message here creating thumbnail, and I'm just going to print out thread.currentThread.getName, so I can see how many threads are working off the images and what their respective names are. All right, that sounds good to me. Let me just run the app against, a directory on my PC with a lot of images. Right, I can already see, by the way, let me just, stop this right here. I can see that now we have several threads, worker thread number 7, 12, 5, 4, 13 from a fork join pool, creating thumbnails in parallel. That actually looks pretty good to me, but it almost seems to be too good to be true. Well, let's run this code on my NAS again. All right, I just logged into my NAS. I'm executing the Java class, and no, I'm just getting the main thread here, just one thread again, converting all the images. Why is that? Now, I can tell you it took me quite a lot of time to find out what was wrong with my code, and I didn't only need time, I needed some luck, and also Tagir Valeev as my co-worker who pointed me in the right direction. Because there's nothing wrong with our code, it is just that before Java 19, parallel file streams were actually not parallel, even though you called that method, they were sequential. And then Tagir actually submitted a patch to the JDK to make the parallel file streams work, but that only starts with, from Java 19 on. Locally, I have Java 19 installed. On my NAS, I have Java 17 installed. Hence, we see that different behavior. This also means that using parallel file streams for us now isn't the best option, and I'm just gonna, fall back to using a good old executor service. But question to you, how would you have found out about that? Would you have written a CI matrix, with different JVM versions and running them and, finding out somehow that, parallel streams work? How would you have tested that? Let me know down in the comments. But for now, we're gonna check out the executor service. All right, let's use an executor service instead of my parallel file stream. So I'm just going to delete the parallel method invocation. Up here, I'm just going to go executors, new fixed thread pool for now. And I'm going to end up with an executor service. That leaves me with the question, well, how many threads should I actually use? Now, a bit of theory. I know that, reading and writing the images will take some I/O. But in fact, the actual conversion to a thumbnail is pretty CPU heavy. So with 20 million caveats applied, I'm just going to assume I want as many threads as I have CPUs on my machine. So I'm just going to go with runtime, get runtime available processes. Now, it could turn out that I/O is a much bigger factor, but the thing is we need to actually test this later on. But as a general naive assumption, I'm just going to think, hey, CPU heavy workload means number of threads equals to available processes. And then, as I said, later on, we're going to check out if that is actually the most optimal way. Now, we have our executor service, and then the only thing that's left to do is actually call executor service submit and submit a couple of runnables or tasks. And what we need to do here is I'm just going to cut and paste, these two lines into my executor submit method. Now what we actually want to do is, being good citizens, we need to call ExecutorService shutdown, right? And as the Java doc says is that, the submitted tasks are still being executed, but no new tasks, will be accepted. So that is that. And then we call ExecutorService await termination to find out, or to wait until all the tasks have been processed. And for that, I'm just going to use a ridiculously high number of, let's say, 10 hours at the moment. And we'll need to figure out later on, if there's a better way to, specify the right time for this termination period. But this should hopefully work. Let's try it out and run the application locally. Right, as you can see, I have a couple of threads working off my images. Pretty cool. So let's try out the same thing on my NAS. Ready? Let's give it a go. And yay, you can see now on my NAS, I also have multiple threads here. Specifically, I have 4 of them because my NAS has 4 CPUs. Pretty cool. We made the code multi-threaded. All right, time for benchmarking. Let's see if what we wrote actually has any effect at all on the runtime. What I did is I have now 2 versions of my app.java class on my NAS. One is single-threaded, one is multi-threaded. I'm just going to use the single-threaded one, right? We're working off this directory. We can see that my CPU usage is roughly around 50%, hovering about that. And I'm going to see you back in a couple of seconds or minutes, and we're going to find out how long the whole process took. Here we go, 357 images took 72 seconds, so a minute and 12 seconds to convert. Now let's find out how the multi-threaded version runs. Ready? Okay, let's go. You can see now multiple threads, are working off the images. It already looks a bit faster. CPU usage is quite high, 92%, which is good, which means we're using as much CPU as possible. Now let's wait to see how long this run takes. Yay, we're done! 357 images were created, and now this took 45 seconds. So we almost shaved off a good 30 seconds, converting these images on this one single folder, which is pretty cool. Now, let me know down in the comments if you want to see an episode where we dig deeper into how will we get the most optimal number of threads, converting our thumbnails. And then there's one looming question, by the way. Is ImageMagick multi-threaded or is it single-threaded? And what happens if we have multi-threaded ImageMagick with a multi-threaded program? Does that influence things? Questions over questions. But for this episode, I don't want to cover any more threads. Instead, I want to have a look at our image storage because we also need to fix that for multi-threading. So at the moment, our program just takes any image it finds, creates a thumbnail for it, and puts it into one directory, the thumbnails directory, which is essentially my user home directory, the .photo subdirectory. And we just put every file there with its original file name. And obviously what happens if 2 images happen to have the same file name, you would have a clash. At some point, if we just put 1 million files into that folder, the folder would explode, so to speak. Or more specifically, folder performance would suffer. And in any case, what happens if our executor service, for example, if there's multiple threads, working off the same thumbnail, will there be clashes? Will there be problems? And we need to take care of all these issues. First off, we're just going to start with the file name issue. And what I want to do is, instead of using the original file name, I want to use a hash for the file, right? So in fact, I want to do something like, first of all, I want to turn my image into a hash. And for that, I'm going to create a new method called hash, right? I have it like so. And now the question is, what hashing algorithm are we going to use? There's plenty of them from MD5, SHA1, and whatever have you, but I'm following a performance-oriented programmer called Casey Muratori on Twitter, and in one of the threads he mentioned that nowadays for projects starting out, he would just recommend the Blake 3 hashing algorithm, which is pretty cool. You can look it up here on its GitHub page. And as it happens, there's also a separate project, which is a Blake 3 implementation in Java, albeit unoptimized. Still, we're going to use that for now. We can do some benchmarking later on again. So I'm just going to copy the Maven coordinates, go back into my project, pom XML file, just going to paste it in here, reload the Maven project, and we should be good to go. Actually, I just quickly went back to the project's GitHub page. I'm going to get some example code. I'm just going to copy and paste that. Right, back inside my hash function, here is the code. I'm just going to make sure the imports are right. And actually, I don't want to use, Java's old file API. Unfortunately, it looks like that this Blake 3 implementation doesn't understand the new path API. So what we're going to do is, I'm just going to have a quick look inside how this, file method is implemented. And then you know me by now, I love copy and pasting some code. So I'm just going to replace that call here, right? Like so. I'm just going to use, files.new input stream on my image, like so, a bit of the new API. Have a new catch clause. Actually, at the moment, I don't want to throw a new runtime exception. I just want to return, not available, for example, as a hash. We need to take care of that later. Yeah, it's not perfect. And here I just want to return the file hash. Now there's only, to fix that API call, let me just call hasher.update. I hope this code is fine. And whenever I see these magic constants like 4096 with the new input stream, I'm thinking of kind of where did they come from. I usually default to looking at the, default Java classes. And here the file input stream has a default buffer size of 8192. So I'm just going to use that. But in fact, hopefully this method, let me inline the variable, is going to return me a nice hash I can use. Not so fast. What did we just solve with the hashing? Imagine we had the same image, the image content, 5 different times. We get the same hash back, and then in the end, we just store, one thumbnail instead of these 5 thumbnails. That is perfect, but we're still putting all the files, all the hash files into one big directory. And here, what I'm going to do is, I had a look at, quite a while ago at how Git, for example, internally stores files. What Git actually does is, it takes the first 2 characters of your hash and creates them to a subdirectory, essentially, right? And then your file name is the rest of the hash starting from the 2nd character on. So this is your file name like so. Okay, now let's refactor things a tiny bit, because this down here is, the thumbnail path, the path where you want your thumbnail to be created. But it shouldn't just be the thumbnails directory resolving the original file name. First, we want to get the subdirectory. And inside the subdirectory, we want to, get a reference to our new file name, which is the hash or part of the hash. And in fact, what I want to do is we need to tell the create thumbnail method, ImageMagick, what file format do we want to have, JPEG, PNG, whatever have you. I'm going to go with WebP. If you don't know what WebP is, please look it up online, because it's somewhat of the successor to JPEG and PNG. And most popular platforms like Reddit, whatever, use it for their thumbnails. Right, so we have that. We need to do a bit of maintenance though, because this here, let's see, our subdirectory here, it could be that it doesn't exist yet. The first time we run this method. So what I'm going to do is I'm just going to check if files does not exist, subdirectory, then we're going to do a files, create directories, and then subdirectory like so. Unfortunately, that throws, an exception. So again, I'm just going to, print out the stack trace. I don't want to throw a new runtime exception. It's a bit ugly, and we could potentially, pre-create these subdirectories, because there's only so many combinations that you can have. But for now, I'm just going to go with that. Now we have plenty of code inside here, and I'm just going to, extract everything here into a new method, into get thumbnail path, for example. And we'll need to figure out if there's a better name later on. But let me just quickly double check. We're getting the Blake 3 hash. We're getting the subdirectory, the file name parts out of it, making sure the subdirectory exists. And then we simply say, well, the thumbnail path is our subdirectory, and inside here resolving the file name, the hash plus .webp. That looks great, to be honest, and that should simply work. And before we run this now, one tiny last refactoring, because our create thumbnail method actually returns us if the call was successful. And only if, it was successful, I want to, increment the counter so we get the right number of converted thumbnails on the command line. Now let's try this out. Again, I'm going to run things locally and let's see what happens after the program is finished. All right, here we are. Yay, this seemed to have worked, because when I scan my run window, I can see now I have the photos folder, I have a subfolder here, right? Parts of the hash, and I have the rest of the hash followed by WebP. And in fact, I can see that in total 353 images were created successfully to thumbnails. That took 35 seconds here locally. That is pretty cool. And just to double check in Windows Explorer, here I'm in my user_marker.photos folder. I have all my subfolders, all the possible combinations. And when I go to the first one, for example, I have a nice little WebP photo, which I can open up, right? And here is, that is actually part of Munich where I live. So pretty cool, everything is working as expected. Oh, hold on, is it really working as expected? Now, what happens if, for example, I have this test image here in my project sources, I just copy and paste it, right? And give it a new file name. So I have, the same picture twice, just with different file names, but there will be the same hash will be created. Now, what happens if my executor service runs two threads in parallel and tries to convert the same thumbnail to the same target file in parallel? Will there be a problem? Let me know down in the comments. Also, let me know how we could potentially work around that problem and fix it. But that is enough waffling for now. All right, what are we going to build next? You might have noticed something critical. Now we're successfully, creating our thumbnails with the hashed file names, but we're throwing away the original file name, which is obviously a bit bad. And what we need to do is we need to store the file name and plenty other data, metadata about the image. And we're going to do that and, put all the metadata into a database table in the next episode. What do I mean by metadata? Well, you don't just have the file name, but you have, for example, the GPS coordinates, if they're available, for where the picture was taken. And that opens up another total can of worms. In short, I can't wait. Hope you liked this episode. Sayonara.